All right, I'm recording at this point. Welcome, happy Friday. Here we go. It's Advanced Algebra with Financial Applications Day, and we are going to be working on Independent Living, Section 1. All right, Independent Living, Section 1. Going out to that Google form. Should look like this. Oh, actually, if you've already responded, it'll say you've already responded. You're going to edit your response. And then I'm going to need to blow this up so everyone can see it. There. That's too much blown up. All right, Chrome, don't be an overachiever now. Okay. I'm just adjusting my windows. Boop, 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 boop. And there we are. Okay. I'm going to get rid of this open blank form, and I'll click on that to get rid of it so it's not there. Four learning targets. I can calculate the affordability of rent. That's what we did on Monday, which was basically find out whatever your monthly income is and find out what 28% of that is or thereabouts, right? Somewhere between 25 or 30%. You don't want to spend any more than 30% of your income, monthly income, on rent. Learning target number 2, I can determine the relationship between square footage and monthly rent. Well, here's the here's the thing. The bigger the apartment you want to rent, the more the monthly rent will usually go up. You know, in general, the bigger the apartment, the more it costs to rent it. 3, I can determine lease signing costs. I did a video up on this. This was your Wednesday assignment. Example 3, determining lease signing costs. It was pretty easy. There's a video there to help you. And then yesterday and today, we're going to be calculating moving expenses. I can calculate moving expenses. So I am scrolling down. I'm skipping my name and learning targets. That's already done. I'm skipping all the stuff after example 1. So there's example 1. That's what we did. We answered Genesis, the 2 Genesis questions, and then I made you do the Miriam and Najalee's question on your own. And then we did the example 2. There's example 2. We put this data in our calculator. We ran the regressions. We got the equation, and then we messed around with how to interpret the equation, right? So there's the equation, and we found out, like, okay, if it's an 880 square foot apartment, if the apartment is 880 square foot, stick in 880 in for X in the equation, and then we'll find out how much the monthly rent is, right? And then you were going to answer, like, well, what will be the cost of an apartment that's 1,550 square foot? How much will that cost in rent? And then I gave you an amount of monthly rent, and you were going to tell me how big the apartment was in square feet. And then this was the Wednesday. This was example 3, the Wednesday assignment, where it had, there's, various fees that go into renting an apartment to be aware of. There can be application deposit fees, credit report fees. Sometimes they ask for the first month's rent, the last month's rent, a security deposit. These kind of things you got to put up right before you move in order to get in there. And now we're moving past. Yesterday we did example 4. Example 4 was systems of equations. We used the situations to make an equation, right? Like 6 hours of loading and unloading with 5 hours of packing and unpacking. We turned that into an equation, like 6 times X, 6 times how much they're charging us for loading and unloading per hour, plus 5 hours of packing and unpacking. So 5 times how much they're charging us per hour to pack and unpack. We know that's going to equal 720. We do that with a second equation, 4x plus 2y, that's 4 hours of loading and unloading, 2 hours of packing and unpacking. We know that's $400. With 2 equations, we can solve for 2 variables. So we got both of these equations equal to y. We did that manipulation of algebra to get both equations equal to y. We stuck those in our calculator, which allowed us to get 2 little lines, and we looked at the table for when the y1 is the same as the y2. That will give us our x and our y. We also talked about the intersection, using our calculator to find the intersection. And then we did the we move u problem right here. We did the we move u problem right there. And then after that, there was some move a lot questions and move a lot. Yep, you were supposed to answer all the move a lot questions. So here we go. This is Friday. Happy Friday. Systems of equations elimination. Systems of equations can also be solved algebraically, not just using your calculator. The elimination method is the process of algebraically manipulating one or both the equations so the coefficients of one set of variable terms are opposite and will drop out when the equations are combined as shown below. All right, so here's our situation. Samantha Samantha is moving from Madison, Wisconsin to La Crosse, Wisconsin. She will do all of the packing and unpacking by herself with her brother. The moving company quoted a price of $1,250 for 8 hours of loading and unloading and driving 130 miles. The company quoted the same price if the truck drives an extra 30 miles to pick up Samantha's brother. Samantha figures that with her brother's help, she only needs to hire the movers for 6 hours. How much does the company charge per hour for the loading and unloading? How much do they charge per mile for the driving? All right, so that's the situation. That's the word problem. That's the kind of word problem you might expect to encounter. How do we solve it? Well, here's the solution. We're just going to let x is going to be a variable in math. When we don't know what a number represents, we don't know the exact number, we'll just give it a variable name like x. We'll have x represent the hourly cost for loading and unloading, and we'll have another variable, y, represent the per mile cost for renting the truck. So here's the situation. Situation without brother. Without the brother, 8 hours of loading and unloading, mileage 130 miles. Situation with the brother, 6 hours of loading and unloading, mileage 160 miles, an extra 30 miles of driving because I got to pick up the brother. The cost of situation, let's see. Oh, they both equal the same? Interesting. Okay, so we're going to write the equations that model each situation. All right, so it's going to be labor cost plus the truck rental cost gives us our total cost. All right. Yes. So 8x, we're going to write this as 8x, that's 8 times how much they're charging us per hour for loading and unloading, plus total truck rental cost. That's 130 miles times whatever y is. That's the per mile charge they're charging us. They say that's going to equal 1,250. Or the other situation is the situation with the brother. It's 6 hours of loading and unloading, 6 times x, which is how much they charge for loading and unloading, plus 160 times y, which is how much miles they're driving. It's going to equal the same, apparently the same price. And we're going to use elimination this time. We're going to use elimination this time in order to find out what one of these variables are. Here is how that works. So what we'd like to do is we'd like to add up these two equations in a way that gets rid of one of the variables. And if you remember from just kind of like simple algebra, if I do something on one side of an equation, I got to do this exact same thing on the other side of that equation. So in this case, what they're going to do is they're going to focus on it looks like they're going to focus on the x variable. They're going to try to get rid of the x variable. All right, how are they going to do that? They're going to multiply each of these equations by a number, which makes these two numbers, these two x coefficients the same, but one of them is going to be positive and one of them is going to be negative. So they're looking at 6 and 8, and they're saying, what's the lowest common factor of 6 and 8? Like what number can we multiply these two to be where it goes in nicely? And did you have an answer?
He said 2.
2 is the lowest common factor with them. Good. Maybe I'm saying it wrong. I'm saying. Yeah. Lowest. You're right. Actually, right. You're not wrong. The lowest common factor would be 2 because they both divide by 2. So I like your thinking there. Okay, so GCF, greatest common factor. Is that what we're looking for?
Yeah.
Is that the technical term here?
So if you guys do this, if you were to say, you go 8, 16, 24, you do 6, 12, 18, 24, you're yes. Well, for you to get from 8 to 24, you have to raise that to get to 24.
Yeah.
For you to get from 6 to 24, you got to raise that to get to 24.
Yeah.
24 is the magic number. So if it's 8, how do you go from 8 to 24? Everything on that 8 has to get multiplied by 3. Everything in the parentheses.
So for those of you at home, what Mr. K just said, he goes, if you keep multiplying 8 by like 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and then look at, multiplying 6 out by various integers. 6 times 1 is 6, then 6 times 2 is 12, 18, 24. 24 and 24 are the first number they both have in common as you multiply them out. So if you go down here, look what they're doing. They're going to try to get both of these coefficients to be 24. If they can get one to be a positive 24, and then get one of them to be a negative 24, then if I add these equations together, I eliminate. That's why we call this process elimination. If I can get both the coefficients in front of the x to be the same number, but with a different, one with a negative sign, one with a positive sign, I can add the equations together, and then the x's will cancel themselves out. So in order to make 8x become negative 24, they're going to multiply everything in the equation by negative 3. Right? If they multiply everything in this equation by negative 3 times 8x becomes negative 24x. Negative 3 times 130y becomes 390y. And then we have to also do it on the other side of the equation. Negative 3 times 1,250 becomes negative 3,750. So they just multiplied the entire equation by negative 3 in order to get this negative 24x. In order to make this 6 become a 24, they decided to multiply the entire equation by 4. Right? 4 times 6x is going to be 24x, positive. 4 times 160y is going to be 640y. 4 times 1,250 is going to be 5,000. Now they have that set up like this. Negative 24x minus 390 times y is going to equal negative 3,750. And if they add that equation with that equation, these two, the x will cancel. The x will cancel. If I add 640y with 390y, I get 250y. And if I add 5,000 with negative 3,000, oh, let me try that again. If I add 5,000 with negative 3,750, I'll get 1,250. And then this equation becomes a really easy equation to solve for, right? It's just a number times y equals another number. I'm going to divide by 250 on both sides, and I'll find out what y is. Y is 5. That means they're charging $5 per mile. Is that possible there? I suppose it's possible. Just trying to think, that seems pretty steep. Yeah, $5 per mile. That's pretty steep, dang. Okay. They're charging $5 per mile. And then once you have the y, what y equals, you could go ahead and find out what x equals, right? You could just stick 5, like you take one of your equations, one of your original equations, stick 5 in for y. Well, 130 times 5 is 650. And now you only have one variable, and now you can solve it with regular skills of algebra. Subtract 650 from both sides. You'll get 8x equals 600. 600 divided by 8 gives us 75. They're charging $75 per hour. I kind of feel like I want to show you something. And I guess because until you see it with something simple, maybe this is hard to visualize. Let me take a look at this. Let's say I got 2 plus 2. 2 plus 2 is 4, right? Everyone agrees? Anyone want to disagree? Good. All right, and then let me do like 5 plus 8. 5 plus 8. 5 plus 8 is 13. Hopefully we're all in agreement here. And I want to show you something that maybe you didn't realize. If 2 plus 2 is 4, oh, I wrote 12 and I meant 13. My bad. That was not going to work out well for me if I did. This is why I should not talk and write at the same time. I cannot chew bubblegum and talk at the same time, apparently. If I know that 2 plus 2 is 4, and if I know that 5 plus 8 is 13, then if I add both of these equations together, I should get a true statement. If I add 2 plus 5, that should be 7. If I add 2 plus 8, that should be 10. And if I add 4 plus 13, I should get 17. And looky there, 7 plus 10 is equal to 17. So if you know that 2 equations are true, if you've got 2 equations, if you know that if both of them are true, then if you add them up, the sum should also be true. So what we're doing here is what we're trying to do is we don't actually have the numbers. So we're trying to figure out like, well, how can I manipulate the equation so the numbers look the same? Like for instance, I could take this equation up here, I could multiply the entire thing by -5. if I multiply the entire thing by -5, I'll get, now I need to make this kind of equal to, I'll get -10. Go slow, let's go smaller. Probably should have done this with text, -10 minus 10 will equal -20, right? -5 times 4 will be -20. And that makes sense. -10 minus 10 is going to be -20. That's for sure. And if I multiply all of this times 2, I will also get another truest statement. All right, so that'll be equal to, I need like parentheses in here. I need to keep these straight. 2 times 5 is 10. 2 times 8 is 16. So plus 16. And then 2 times 13 is 26. And look at that, that's absolutely true. 10 plus 16 is 26. Everything's working out good in life here. Whoops, I didn't want to do that. I wanted to kind of go from around there. And then if I add these two equations up, notice that the -10 here and the 10 there, they kind of cancel, which means I can ignore them. And I can just say that what's -10 plus 16? Well, that's going to be a +6. If I add these two equations up here. And then what's -20 plus +26? That's going to be 6. 6 equals 6. It all stays good, right? This is the math we're doing when we're doing elimination. We're multiplying the entire equation by a number, which will get these front coefficients to cancel each other out. And we know it'll be true. So that is the math that we're doing there. All right, so just kind of give you an idea of, hopefully that makes things a little easier to understand. Let me go back to what I was doing. Boop. All right. So we have these two equations. We've got these two equations here. They're multiplying each equation by a number, which will get the front number to be the same with one positive, one to be negative. That cancels them out. And then if they add what's left over, they'll have an equation with just one variable. And that's pretty easy for us to solve. When we have an equation with one variable, we can solve it pretty easy. And then once we have what y equals, we can easily find out what x equals by sticking that number in for y into our old equation and then solving for just one variable here. So that is the step. I think I don't have any practice for you today. So it's just go ahead and give it a shot. I guess I'll walk you through the first one or two. I'll do the first one. Yeah, I'll do the first one and then I'll have you do the rest. Samuel's moving from Cicero, which is outside of Syracuse, to Rochester. His moving company, We Move It, quoted him 1,000. We move it. $1,012 for 9 hours of loading and unloading time at 100 miles of driving. And they quoted him $908 for 6 hours of loading and unloading if they drive an extra 25 miles to pick up his brother. It's nice to have those brothers that will help you move all the time. Apparently everyone's got a brother that will help them move. Write an equation that models the situation without the brother. Okay, here I go. I'm doing the equation without the brother. That's this top one here. Situation without brother. It's going to be 9 times, I'm going to give it a variable. I don't know what the number is, so I'm just going to call it x. 9 times an unknown number plus 100 miles driven times an unknown number y will equal 1,012. 1,012. That's how hard it is to come up with these equations, right? It's 9 hours times they're charging me something per hour. I don't know what it is. I'm going to call it x plus 100, and they're going to charge me a certain amount per mile. Will equal that cost. If the brother comes along, it'll be a slightly different equation. I can use both equations to solve for x and y. And then that's what, and if you want to do the elimination thing, by all means, if you feel like you've got it, if you want to just solve it with your calculator using the trick we showed you last time, I'm not going to know the difference. Just saying. I would say try to do it with elimination. Try to practice that skill, because if you ever take a Regents algebra course or a test ever again in your high school career, systems of equations is a useful skill. Elimination is a useful mathematical technique to be able to use. But if you can use technology, that's good too. All right, so I'm gonna stop sharing. I'm gonna leave it there. I'm gonna stop the record. Happy Friday, everybody.